Okay, so we're going to be optimizing with exponential functions. So we're just going to go over a few rules before we start. If our function is the exponent with the base e, so Euler's number, to the power of a variable, then the derivative is identical. Okay? So this is one we'll have to kind of memorize as we go through it. And actually, you know what? I'm going to go through these first and then explain these as we go through. So if we have a function that is an exponential function, so our base is b and our exponent is the variable, then the derivative of this function is the original b to the power of x multiplied by ln times the base. Oopsie. Okay. And with that being said, if we have an exponential function where b is the base and our exponent is a function, so something larger or longer, like a polynomial involving the value of x, then our derivative of the function is the original again multiplied by ln b, so nothing's changed from here. But we then will have to multiply the derivative of the exponent, or that function that is the exponent. So with that idea, let's go back up to here. This is an exponential function. Our base is e in this case. So technically it should be multiplied by ln e, but ln e equates to the value of 1, and therefore it doesn't change the other part of our question. With that being said, same idea again. There should be a multiplied by ln b in the middle, but b being the exponent of e, ln e is again just the value of 1, so we don't need to include that part into the equation. So these equations are essentially identical here. So if you're going to memorize any of them, memorize these two and just remember that ln e is equal to the value of 1. Okay? So let's get into our question. The effectiveness of studying for an exam, you guys should write this down, depends on how many hours a student studies. Some experiments show that the effectiveness, which is denoted as E, is put on a scale between 0 and 10. Then the effectiveness in reference to T, I assume T is the number of hours spent studying, is equal to this equation. If a student has up to 30 hours for studying, how many hours are needed for maximum effectiveness? Okay, so effectiveness is measured from 0 to 10. You have up to 30 hours to study. Okay, so we want to optimize this, which means your parameter here is T is going to be between studying for 30 hours and not studying at all for 0 hours. Okay. How many hours are needed for max effectiveness? Okay, so we're looking for maximums. Well, we have our parameters, so we'll have to test the maximums after at 0 and 30. We also want to find in this function where the tangent to the derivative would be 0. So we want to derive this to find another critical point. So we're going to take this effectiveness. E at t is equal to 0.5. 10 plus t times e to the power of t negative t over 20. Okay. So looking very complex. We'll go into this. We need to derive this function. So there's a whole lot of rules, and we'll go through them. We'll go through them step by step so they make sense to you. Okay. So we're going to derive this function. E prime t is equal to. So this is, to start off, a product rule. What's the derivative of 0.5? 0. So when I take that and I keep the original here, 0 times all of this will give us 0. So that's out, right? We don't need to do that part. So let's focus on the brackets next. Let's work on our brackets. So our brackets, inside our brackets, derivative of 10 is 0. Okay, so that has also been eliminated. Really, we need to focus on this part of our equation here. Okay, so let's focus on specifically that part of the equation. We have our t multiplied by e to the power of negative 10 over 20. So we have to remember our rules from before. This in itself is another product rule. So to start off, we're going to derive t. What's the derivative of t? 1. Okay, so 1 times what's left over here is just going to be what's left over. So we have e to the power of negative t over 20. That's the first part. Then we'll have to add we'll have to derive the second part of the function. We'll keep the t, so it'll be t multiplied by the derivative of this. So I'm going to focus on this down over here, e to the power of negative t over 20. So when we're deriving this, recall that because this exponent is a function, the derivative of it will be the original, which is our e to the power of negative t over 20, okay, multiplied by ln of the base, that's ln e. What's ln e equal to? 1. So we don't have to include that part, but we will have to multiply it by the derivative of the exponent. So I'm going to break this down again. We want to derive this exponent. The exponent here is negative t over 20, okay? And I'm going to break that so it looks more like a variable and a coefficient. So it looks like negative 1 over 20 times t. This is much easier to derive. What is the derivative of that? Anyone know? Negative 1 over 20. So that means we'll need to multiply by negative 1 over 20. Okay? So let's scroll back up here. This is what we'll be putting into this bracket here. So we have e to the power of negative t over 20. No, it's really small there. Times negative 1 over 20. Okay? And I'll put little brackets around them. So here we've now derived, and because this cancels out, we derived this part of the equation and we were given this. I'm going to write it again in black and we're going to see if we can't factor something out. So e prime t is equal to e to the power of negative t over 20. Okay. I'm going to multiply t and the negative 1 over 20 together to give me subtract t over 20 times, and I'm going to put this in brackets so we can see it simply because it is multiplication, negative t over 20 as an exponent. If we look now, this value and this value are identical. So because they're identical and in different terms, we can common factor them out. So we're going to common factor out e to the power of negative t over 20, which will leave us with, when we do common factor it from here, what value do we get? 1. And we common factor here, we're only left with minus t over 20. Okay, so this is our derivative function with some factoring involved. Now remember, when we derive this, the whole goal is to set it equal to 0. Okay, so we want to set this equal to 0 to find out critical points. Our critical point 0 equals e to the power of negative t over 20 multiplied by, so this is a function in itself, let's say, multiply 1 minus t over 20. Now, I want to show you this. This is an exponential function. E is a value. Okay? And remember, we need to multiply to 0. So we need to think of it like this. Split each of these. I want to split this value, where I have 0 is equal to e to the power of negative t over 20. And we want to have 0 is equal to 1 minus t over 20. Okay? And I want to address the one on the left first, our exponential function. Can I get an exponential function that's going to cross our y value at 0? Yes, no, maybe so. Let's find out. Let's actually bring up a graph here. I have my graphs. Give me a sec. There it is. Hey, there it is. Perfect. I have it ready for us. This is our exponential function right here. So let's put it to the other page. This is our exponential function, and if we notice, when I zoom in, extremely close, it never is going to quite touch the x-axis. In other words, it will never equal 0. Okay, so because that value will never equal 0, okay, we don't actually have to equate for this t value. This will never equal 0. So we don't have to worry about that t value. It can be any t value. No matter what number, it will never give us a 0. But over here, we do have to worry about this t value. So let's solve for it when it would give us 0. Okay, and when would it give us 0? We bring the 1 over, we get negative 1 is equal to negative t over 20, which is going to give us t at 20. Okay, so our other critical value is when the time is 20. So let's scroll back up here. We have to test at 0, 30, and we're also going to have to test at the value of 20 into the original equation. We'll plug them all into the original equation and find out which is the most effective on a scale of 0 to 10. So let's go down. The original, write it again, E at t is equal to, I do not have it memorized, what is it? 0.5, 10. 0.5, 10 plus e to the power of negative t over 20, is that right? Let's find out. Yeah, that's it. Okay, so the values we're going to plug in are at 0, 20, and 30. Somebody have a calculator, maybe help us out along the way here. So e at 0, I'll do that one. I think I can do it. Did I miss something? Oh, that's right, there is a t. Thank you. Oh, it makes it even easier for me. Great. Okay, so I'll do e at 0. And while I write these out, if somebody doesn't mind trying that on a calculator so we can get answers quickly. So 0.5, 10 plus t will be 0. So that's going to make this part of the equation extremely easy. 0 over 20. No matter what this equates to, 0 times that will be 0. So we're left with 0.5 times 10, which is going to give us 5. So on a scale of 0 to 10, this is a 5, right in the middle. So not studying at all, it's in the middle. You get a 5 for effort. Amazing. Okay, let's try 20, which gives us 0.5. 10 plus 20 multiplied by e to the power of 20 over 20, which is essentially e to the power of negative 1. Okay, we'll get a value there. And I'm just going to write the other one. Hopefully 2 people can help us out. I'll write 30 in also. This will be 30 times e to the power of negative 30 over 20. Okay. Does anybody have an answer for the first one by chance? 8.7. That's pretty good. On a scale of 1 to 10, you get 8.7 for 20 hours. How about 30 hours? 8.3. So in terms of effectiveness, which I assume means using your time wisely, it is most effective to study for 20 hours for a test, which I'm sure you all do. Right? That is considered the most effective way in this study.